I hope you are able to see my screen now. And by the way, I haven't muted anybody. So if any one of you want to talk, you can just unmute yourself and you can talk at any time. Feel free to interrupt. All right. And yeah, I'll be talking. I'll be taking approximately an hour's time to talk about what is this big data and Hadoop. And this is going to be the agenda. I'll be talking about big data and what is the difference between Hadoop and big data, the 4 V's, Hadoop core, and then some technical details about Hadoop, right? And though question and answer session is kept at last, feel free to stop me at any point in time, and let's make it a bit of interactive rather than a simple theory kind of session, right? Good. So here is about me. I'm working as a senior Hadoop architect at an MNC based out of Hyderabad. I have got overall 11 years of experience. Out of that 11 years, last 3 years is into this Hadoop and analytics. Rest is into Java. I am a Cloudera certified developer as well as administrator. So, I mean, I have hands-on on both development and admin activities, interestingly. And before getting onto Hadoop track, I was basically a Java developer. And I closely work with US clients. What I mean by this last but statement is, apart from doing my full-time job on this kind of trainings, in the past I have done some consulting assignments, like visiting the customer place, understanding their problem, and then providing a solution to the problem that they are trying to solve. And in addition to that, doing a POC for the design architecture. So that the teams sitting there in their own office can actually go and implement that actual project. And I have already conducting training for Hadoop for 40 plus batches already. Around 800 plus students is what I have trained so far. All right, moving on. Uh, are you all with me? Any questions? Any points you want? Maybe just to make the session more interactive. It is good if somebody can talk about what are your expectations from this session. Hey, I joined this session for this reason. I'm looking for this. So if you can set the expectations, I will try to cover that. Of course, that can be taken as a question also. But if anyone want to set the expectations, I can. It's up to you. Okay, great. Sandeep is talking about understand the concepts and the prospects in future. That's very much the intention of the whole session, sir. Thanks for that. Yeah. Any other expectations from anyone? What is that you are looking for? The takeaway from this 1 hour time spent.
Hey, this is Srinivas. So I just wanted to understand basics and to little bit into the implementation details and what problems it is trying to solve. Hadoop. Um, what what do we have at this moment as a legacy system, and what is Hadoop trying to fill in? And I mean, what kind of challenges Hadoop may face as well. So those are typically my expectations from this session. Thank you.
Nice, Srinivas. Yeah, definitely. I'll cover those in due course. Yeah, and if any of the topic is specifically not covered, but of course we can discuss it after this, right? Yeah, Manas, if you have any questions, of course we'll hold on to the questions. But I mean, the idea here is to understand the expectations, right? So I think, yeah, a fair understanding. 2-3 persons talked about it. Good. So let's go ahead and continue. Right now, you might heard about Hadoop through your friend circles, through some advertisements, and sometimes you might also come across this word big data, right? And though some of you might know, But many times we everybody will think, hey, what is this big data and what is this Hadoop? How they are related to each other? So big data is a concept. Big data is like some data with the unique characteristics of these four. So if some data is very large, that is volume. If some data is getting added at a very high rate, velocity, and if the data is in wide variety of formats, it's not just a plain text file, instead it's in a wide variety of formats, then that is variety. And then veracity, that is uh, there is so much of data available out there, and out of that much of data, what is that I'm more dependable upon, what is that I'm that is separating the dependable data from every other data. So these are the four characteristics that differentiates big data from normal data. uh, I'm sure the data is something that we have been everybody deals with in your regular day-to-day work. But if that data, if at all, contains these four characteristics, uh, meaning if it is a large in size, running into terabytes of data, or if it is getting added at a very high rate, like every 1 hour 100 GB, or every day 200 GB, or if the data is coming in wide variety of formats, it could be, yeah, your image file, audio file, video file, and also if some data contains these four characteristics, that's what we call it as big data. And a technology which is intended to solve the problem of big data is Hadoop. So though people use these two things interchangingly, but Hadoop is a technology, and of course currently is the only technology which is intended to process this big data. Now, when we say intended to process the big data, first of all, we should be able to collect that big data, huge amount of data that we are referring to. We should be able to store that data effectively, and we should be able to process that data effectively. So, Hadoop is actually a combination of those three tasks. So, in Hadoop, in a nutshell, will provide you what is expected out of these four characteristics. So it should be able to provide a way to collect the data coming from wide variety of sources. There will be tens and tens of sources from where we can collect the data: internet, sensors, uh, mobile devices, your clickstream data, we can talk about wide variety of sources. So Hadoop is having some systems which will enable us to collect the data effectively. Plus, Hadoop is a system which will provide a way to store that huge amount of data effectively. Plus, Hadoop will provide a way to process the data, meaning running some programs on the data and then making use of the data. So, uh, big data is all about these characteristics. Big data is just a concept, and a concrete technology, of course, made out of multiple components. As you can easily guess, I'm talking about, I have already hinted, three different functionalities what we can expect from Hadoop. So Hadoop is not just a single component, it's not just a single language as such, a language or a database as such. It is actually a combination of wide variety of sources. Okay, we'll talk about that in next slide. So Sandeep, just to answer your question, veracity means there is so much of data available around. Out of that, what is the data that is useful to me to take my business decisions faster and forward? you know if you actually see how much data does Facebook collects every day, how much data does Twitter generates every day, there is so much of data available out there. But out of all the data, what is it is dependable, what is it is not dependable. Out of the whole amount of data that you collect daily, what portion of it is useful to you and what portion of it is not useful to the business. So veracity deals with that point. Okay, I think somebody has raised their hand. I think Jay or Atul, I'm sorry, I missed, you have raised your hand, can you please go ahead with your question? Somebody had raised your hand. Jay or Atul? Okay, no issue. I mean, if you have any question, please feel free to stop me or put your question through the questions option. We can take it up. Okay, so I'm moving on. So the four V's are actually being depicted in a better diagram. If you see, this is a slide I have taken from Go Globe website, and if you see, in every 60 seconds, this much of activity is happening over internet. 25 plus hours of video is getting uploaded into YouTube. 70 plus new domains are getting registered. 1500 blog posts are being made. 168 million emails are being sent. 6,94,445 searches are being made, and so on and so forth. So we're talking about every 1 minute, by the way. So if you look at the data size that we will be arriving at, it will be quite huge. And similarly, the rate at which data is getting added, the slide itself is speaking about it. And then velocity, we talked about variety. If you see, there are wide variety of formats out here. These searches are to do with text data plus audio file plus image files plus video files. This blog posts mostly to do with text data, these videos, and then if you look at the flickers, these are images. So wide variety of formats are there. The data that we are getting right now, the data that the world is nowadays dealing with, is in a wide variety of formats. It's not the plain text data anymore, right? And then out of the whole amount of data, what is it useful to the business, what is it not useful to the business. So these are the four ways that we are going to deal, our Hadoop is going to deal with. Okay, moving on. These are some of these sample areas where this big data has currently being used or currently being researched actively. So let's take one or two use cases here. Maybe this internet traffic or the search quality. And so I'm sure everybody would have used Google search engine. And so have you ever thought of how Google search engine works, and what could be the typical data volumes Google search engine deals with every day? See how Google search engine works. I'm sure some of you knows that, but just to bring everybody onto the same page, there will be some programs which will run periodically every 6 hours in a day. They will keep collecting the data, all the web pages that got added to internet in last 6 hours, and uh, the newly collected data will be indexed, and those indexes will be maintained in some NoSQL databases, some specialized databases, which provides very huge capacity. And then whenever we go and make a search, the search will actually happen against the indexed data, not the original data. So that's how a search engine typically works. And of course, once the search had happened, there will be some page ranking also involved, which decides which pages to be displayed in the number one page number one, which all URLs to be displayed in page number two, and so on and so forth. If you look at the overall process, we'll have to understand three, four things here. One is how to collect that huge amount of data. When I say huge, of course, how many pages typically are there on the internet right now in publicly available data that I am talking about. You know, billions of pages are available, and petabytes or hundreds of petabytes of data is available around the net. Right. So Google will keep collecting the data, and they will store the data at somewhere. So storing petabytes of data itself is a big challenge with the traditional technology. And then indexing the data. When I say indexing, end of the day, some programs has to run on the data and go and execute set of programs and collect the results. So here another problem that traditional technologies might not be able to handle it effectively, because we are talking about running a program on uh, hundreds of terabytes of data, and that too it has to happen every 6 hours. So traditional technology definitely will go and fall flat in that area. And the third one, go and maintain your indexes in a separate databases. If you take the traditional Oracle or DB2 traditional databases, they're not designed to handle this huge volumes of data. And unfortunately, Oracle or DB2 can't handle that much volume, that much load. So that's another area where specialized databases are required. And of course, that's another area where Hadoop and big data is coming into. And the last one, the page ranking part, deciding which pages to be displayed, which pages to be omitted. In that, it has to take care of the spam pages. It has to take care of the obscene websites. It has to take care of the government regulations. In some of the countries, some of the pages are not allowed to be displayed. It has to follow the legality. So all these things is the fourth stage. And if you look at the overall Google search engine work, this has to happen very dynamically. It has to be a continuous ongoing process, and the data that it deals with is quite huge, and that's where uh, traditional technology will not fit the bill. And similarly, we can actually talk about some more use cases. um, Maybe, I mean, maybe we'll take a few use cases once we hear few questions from others. But for now, let me move on. Right now, to solve the problem of these four V's, right? The volume, velocity, variety, and veracity. If we attempt to solve the problem using traditional technology like Java, .NET, C, C++, of course we can solve it, but that will be as good as riding on this. Now let's take a simple scenario. Assume, let me switch to note. Let me switch to Paint. Just to explain it a bit better, I switch it to Paint. So take a scenario. Say I have a computer where I have a hard disk. It's my CPU and it's my RAM. Okay, and I have 10 terabytes of data with me. The 10 terabytes of data could be extending the same example that we have taken. Assume the 10 terabytes of data is internet pages that Google search engine had collected. So how it had collected, that's a different part. But assume we have 10 GB of 10 terabytes of data collected from internet through some sources, and now I want to run a program on that 10 terabytes of data. And what the program is going to do, it will do something called indexing process, and the result of it is going to be stored into another database. Now, if I have to go and run a program on this 10 terabytes of data, right? First of all, the data that we have collected has to be loaded into RAM under the guidance of CPU, of course. Right now, if you see, we are having a IO dependency involved here, because the the data, whatever is sitting in hard disk, has to be loaded into RAM. And generally, the transfer of data from hard disk to RAM happen at a speed of 100 Mbps, 100 MB per second. I'm talking about average, so 100 MB per second. So if you look at the 10 terabytes of data, 10 into 10 power 12, which is terabyte, right? 10, this many bytes by 100 MB, 100 into 10 power 6. MB is 10 power 6. So this many bytes per second. So if you look at the calculation, we are still going to have 4 zeros here, which means 5 zeros. 5 zeros means 10,000 seconds. So just to load the data into the RAM, it's going to take 10,000 seconds. So if you look at the converting it into hours, so now we will arrive at I think 27 hours or so. So that is just to load the data, and of course we need to include a few more minutes of time for running a program on that. Right now, if you is there any better way to deal with this instead of simply running that data on a single computer? How about going with this approach? You see, the same data, what I'm going to do is I will go and put it into set of computers. This is one computer. This is another computer. This is yet another computer. And so on and so forth. And this is another computer. Now, the 10G, say this is first one, this is second one, this is third one, and this is 10th one. 10 computers. Now, the 10 terabytes of data, whatever I have, go and divide the data into 1 TB, 1 TB. So 1 TB will go here, and another 1 TB will go here, another 1 TB will go here, and so on and so forth. Now, once I have my data, of course, all these computers will be connected together, and that's what we refer to as a cluster. And when we go and install Hadoop onto the cluster, it will become a Hadoop cluster. So Hadoop is all about processing using set of computers. It's not just one computer, though we can still made a cluster out of one computer, but in a typical productionized environment, we'll have set of computers. The set can vary from 2 to 2000. And at our company, I work for a US based healthcare insurance company. At our company, we have got a Hadoop cluster made out of 200 computers. And in one some of the consulting assignments that I'm doing right now, in a company, they have a cluster made out of 60 computers. At another place, we have a cluster made out of 4 computers. At our company also, we have a development cluster made out of 5 computers. So it's always about set of computers using which we'll go and process that. Now, somebody has raised their hand. Srinivas, please go ahead with your question, sir.
Yeah. So just one specific question about the topic that you discussed just now. About Hadoop cluster can vary from 2 to 2000 computers. So assuming in your case you have 200 system servers, is what you said. In this case, so this is all about just for the storing data, or this includes the collection process and the processing as well,
Good. It involves both storage as well as processing.
and the data collection as well.
Yes, data collection as well. Yeah, that's a nice point. Yeah,
Okay.
data collection as well. Yes, it involves data collection as well. So Hadoop has got multiple components using which we can collect the data from external sources.
Okay. Okay. All right. Thank you. Please go
Yeah,
ahead.
yeah, sure. So now, continuing my example. So here, the 10 terabytes of data now will be splitted into 1 TB each, and that will be kept into 10 different computers. Now, whatever program that we originally thought of, that indexing program, we will rewrite that program using something called MapReduce. That's a Hadoop specific algorithm which is designed to process huge amount of data in a parallel way. So I'm repeating the name, MapReduce. MapReduce. So MapReduce is an algorithm which is designed to process some data in parallel in set of computers, right? And of course, it is originally designed for this Google type search engines only, but later it found applications in many areas, but it is originally intended for this search engine development only. Okay, and of course it is originated from none other than Google only. So Google is the company which has implemented this MapReduce at the very beginning. It is actually based on a research paper published by some professors. Okay, now the data, once it is distributed, will go and run the program in the cluster. Now, whatever 10 terabytes of data it has got, it will be processed here. The 10 terabytes will be processed here. The 10 terabytes will be processed here, and so on and so forth. And all of that will actually happen in parallel. So the parallelization is the key here. Now, how much time it will take the overall? It will take 1 0 will go away because we're doing the work uh, with this. with 10 computers in parallel. Now, if you say, hey, 10 computers is something, it's not sufficient for me. I want to use 100 computers. Okay, then go and divide your data into 100 GB each and go and load your data into 100 computers and run the program in parallel, in which case one more zero will go off. So the program will actually get completed in 100 seconds or so. So this is something that I'm sure everybody can easily make it. So if you have more computers which working in parallel, your overall throughput will actually increase accordingly and vice versa. So here the fundamental idea of Hadoop is we will use set of computers. Set could vary from 2 to 20,000 to 2 lakhs. Right? So set of computers to do data collection, data storage, and data processing. So all these three phases is where the Hadoop is actually having certain components, and these are the three areas uh, which a Hadoop developer typically deals with. Rajiv Kumar, please go ahead. Rajiv, please go ahead with your question. Rajiv, please go ahead. Okay, I'm just continuing in the interest of time, right? So as you see here from my paint, there are two different parts that we are dealing with. Okay, maybe we'll take a bit of questions here. And by now, with this diagram, you would have got a fair idea of what Hadoop is and how is it different from traditional technology. But let's talk little more details about the same. So, can anyone talk about what could be the problem when we migrate from the single computer based system to this multi computer based system? Can anybody think of an issue? Yeah, Sandeep, your point is very valid. Definitely, high-end mainframe computers are actually designed in that way. I know, but to my knowledge, mainframe computers are not having components to collect the data from wide variety of sources. And if you want to interact with mainframe, you have to go and learn COBOL language to do the programming. Whereas in case of Hadoop, you can use a language of your choice. You can use C, C++, Java, Python, Perl, Scala, any language of your choice. And few more advantages like learning Hadoop is very, very easy. As you know, there are multiple components out there like Hive and Pig. If you take the case of Hive, those of you who know SQL, you already know Hive because it supports SQL as is, and you can leverage your SQL expertise to work on big data. And yeah, mainframes is a very costly solution. You are going to lock yourself to IBM, right? In case of Hadoop, it's all open source based solution, and hardware and software both are actually relatively cheaper when you look at the when you compare with the mainframes. And in fact, just to because we are talking about the same point, I'm working for a healthcare company, and at our company we are very big mainframe vendor, partners. All our claim processing engines, majority of them as on today, even today, we are into Hadoop for last 3 years, but even today, majority of the processing is being done through mainframe computers only. However, in last 2 years, we have migrated two such mainframe-based processings onto Hadoop. There are total 17 systems which are working on mainframes in claim processing systems, out of which two we have already migrated to Hadoop, and we have plans to migrate most of them onto Hadoop in next few years. So ultimately, the point is that you know the industry wants to move away from mainframe. Another major reason why we want to move away from mainframes is it is very brittle. If I want to change some functionality, if I want to add some new functionality, it's very, very brittle. If I go and touch something, I don't know where it is going to break. And interestingly, the code is all written in 1970s, and we don't have teams to maintain those big monolithic computers. So that those are few reasons why industry is looking forward. So does my company to migrate to Hadoop. And my enterprise data warehousing nowadays, we call it as data lake, of course. The enterprise data warehouse, it used to be based on mainframe, but now we are migrating to Hadoop based enterprise warehouse. I hope that answered your question. We have a question from Rajiv. Is Hadoop itself normalized the data? Okay, Rajiv, Hadoop will go against data normalization. There are certain advantages when you go away from normalization. Of course, there are some disadvantages as well. I agree the point, but Hadoop, as I said, Hadoop is not just a one component. It's made out of 30, 40 different components. And in some of the components, they prefer to go with denormalization, which is going against your normalization concepts. In that way, the processing will be, more efficient than what it is otherwise by dealing with the traditional databases. And another follow-up question from Rajiv, suppose I write one program for logging sensor data and I made Hadoop cluster in which node data will be saved and how will we process the data. Okay, Rajiv, it's a bit of technical, but yes, when when we go and collect the data and put it onto cluster, right? Hadoop cluster is actually made out of multiple type of computers, and we have something called a data node and name node. So data node is the place where the actual data will be kept at, and the name node is the place where metadata will be captured. But yeah, that's a bit of technical. We'll talk about that in actual class. But for now, let me move on in the interest of bigger audience. Right, so I'm just moving on. Yeah, my back to my question. So what are the typical features that you look for in this cluster made out of multiple computers? In other words, what are the problems we might get when we are dealing with a cluster here? Because we are talking about a set of computers, what if this computer fails, right? Whatever 1 terabyte of data that we have got here, we will lose the data. Even though in the example that we talked about, we have talked about only internet search engine related data, but this data could be as well my credit card data, this data could be as well my insurance data, this data could be as well my telecom data, or it could be any other type of data. So losing some data is something no business will actually accept. So how to address this problem? Yes, Hadoop will address this problem by something called replication. So what it will do essentially is it will maintain multiple copies of data, multiple copies of same data at the different computers. And default is 3, which means when you go and save a file in a computer, in a cluster, sorry, if you go and save some data in a cluster, it will go and stored into 3 different places. And why 3, Anil? Why not 2? Of course, it is configurable. You can make it 1, you can make it 2, you can make it 3, or you can make it to whatever number that you want. In that way, Hadoop provides a mechanism to safeguard against hardware failure. And an immediate question could be, hey Anil, are we not wasting disk space here? Because we are talking about storing the same data multiple times. Yes, definitely. We are actually going to spend little more on hard disk cost because data replication, which means we are maintaining multiple copies. But that we can call it as a kind of disk wastage only, definitely. But Hadoop will make use of that so-called wastage so effectively to increase the performance. So in that way, that is actually well compensated. And one more way to look at it is nowadays hard disk cost is not very high when you compare with the overall computer cost. So it's okay to have uh, same data being maintained at multiple places, right? So that's one way to one solution that cluster has to provide. Another interesting solution is, second part of the solution is ability to process the data. So whatever example that we have taken, say for example we are running that indexing problem whatever I talked about. I have few keywords here in this 1 TB of data. It need to be shared with 1 TB some data sitting here. So I'm talking about joining these two data sets, the data sitting in computer number 1 and the data sitting in computer number 3. So how to coordinate uh, the execution of a program. So these are the, so we are talking about two fundamental problems here. One is how to deal with hardware failure, and how the other one is how to deal with coordination among the processing computers. So Hadoop provides these answers, of course, and the first one is provided by something called HDFS, Hadoop Distributed File System, and the analysis system, the second one, right, analysis system, is provided by something called MapReduce. So in a nutshell, Hadoop is made out of these two, HDFS and MapReduce. And HDFS, as the name says, is a file system. And how is it different from the Windows or Unix file system is, HDFS file system is made out of set of computers. HDFS is a file system made out of a cluster of computers. It's not just a one computer. So the set could be 2 or it could be 2 million also. It could be any number. And just to give you an example, at Yahoo, Hadoop cluster is having a set of 45,000 computers currently. At Facebook, the Hadoop cluster is having a set of 9,000 computers. And by the way, whatever Facebook posts, whatever likes or whatever videos, images that we upload into Facebook, all of them are currently sitting in a Hadoop cluster only, and that Hadoop cluster is actually made out of 9,000 computers sitting in Facebook's data center. Right? Good. So I hope you are following. Any questions I would like to take? Rajiv, it looks like you have a question. So if you have a question, please go ahead, Rajiv. Okay, good. So I'm just moving on. So I will elaborate a little more on HDFS and MapReduce. So these are the two core components of Hadoop. Now HDFS, this is how I think someone had asked this question. So here is what this technical details is. So HDFS is, as I said, is made out of multiple computers. So assume this is computer 1, computer 2, computer 3, and computer 4, and this is computer 5, and this is computer 6. So my cluster is made out of, six different computers here. Okay, now one such computer is going to be designated as a name node, that is a master computer, we can say. And then there is a backup also, and this is a backup master, we can say, right? And we have a set of data nodes. So these are all the slave computers. So this is slave computer 1, slave computer 2, and so on and so forth. Now whenever we go and upload a file, for example, I have a file here, this is a client, and I am uploading a file into the cluster. And for me, it is the master which is the face of the cluster. And as a external client, I will never interact with any of these slave computers. I won't even interact with the backup node. I will only interact with the name node. Name node is just a master. So that is the face of the entire computer. So external systems will simply go and interact with the name node and say, I want to load a file of 200 MB file, for example. Now this 200 MB file will be loaded, will be given to the name node, and the name node will simply go and put it into one of the data nodes. And now whenever I want to retrieve that file back, simply the client will go to name node. Hey, name node, I have uploaded a file at this path earlier. Please get me that file. Now, only difference between our traditional Linux or Windows based file system and here in case of Hadoop is the data is not getting stored into a single computer hard disk as such. Now the data is actually being stored in a cluster of computers. my actual file might go and sit in data node 1, data node 2, data node 3, or data node 4000 also. It can go and sit into any computer. So the name node, as you can easily guess, is a computer which will maintain metadata, meaning which file will go and sit in which slave computer. So tomorrow, whenever the client want to retrieve a particular file, he will simply provide a path. The path is of course based on the cluster. The file will be returned back to the client. So here, now my storage is not limited to hardware of a single computer. Now my storage is actually will be able to provide as much storage as the total combined hard disk capacity of the entire computers connected in the cluster. In earlier case, in case of traditional file systems, the storage capacity of a computer is limited by its own hard disk. Here in case of cluster, storage capacity is not limited. Once we run out of capacity on the 4 computers, we can simply go and add 4 more computers or 400 more computers. So in that way, uh, the cluster will provide you unlimited storage capacity. Though technically there are some issues, but yeah, we can roughly say the unlimited storage capacity. Somebody has a question. In 200 MB file storage, it's set it, or it will be broken into separate files. Okay, Atul, that's a detail, but yeah, I mean, I can elaborate it. But I'm looking about a bigger audience interest. If I get into technical details, everybody might not like. But yeah, as the question came up, let me elaborate. So the 200 MB file, whatever you're talking about, uh, it it might be divided into pieces. It might be divided into smaller units. Those smaller units in Hadoop are called blocks. So those the 200 MB file will be divided into two blocks. First one block will be 128 MB, and the remaining one is 72 MB, assuming that your block size is on 128 MB. But if you say your block size is 256 MB, then your 200 MB file will be divided into only one block, which is of just 200 MB. And similarly, if you configure your block size to be 64 MB, your 200 MB file will be divided into 4 different blocks. First one 64, second one 64, third one 64, and the last one is going to be 8 MB. So it is all configurable. It depends upon how much block size you have configured your cluster with, and the default block size in Hadoop is 128 MB. So just to answer your question, the 200 MB file will be divided into two pieces. We can call it as a block 1 and block 2. Block 1 will be of 128 MB, block 2 will be of 72 MB. And of course, as I said, there is something called replication. So each of the block will be stored at 3 different computers. Yeah, Sandeep, just to answer your question, yes, definitely we can go and add additional machines, additional hardware to the cluster when it is running. There will be minimal effect on the currently running jobs. So that's very nice feature that what Hadoop provides. So we can go and add computers additional capacity at any point in time. And one more good thing about this Hadoop is, any computers can actually be connected to Hadoop cluster. It's not that it has to have a certain type of hardware. Any hardware, as long as you have a computer, you can go and add it onto Hadoop cluster. If you have a laptop made out of 4 GB RAM, you can connect it. And you have another computer made out of 24 GB RAM, you can connect it. I have another computer made out of just 2 GB RAM, I can still connect. Uh, so when you connect heterogeneous computers with different capability, a computer, what how much it is capable, only that much it will contribute. In case of Oracle rack, or in case of Teradata rack and all, of course they will also provide this kind of set uh, network computers, but there will be some restrictions on the hardware. Like all of the computers should be of certain configuration, certain restrictions are there. So here, no such restriction, right? Okay, Rajiv, is Hadoop supports what type of files? Yeah, Rajiv, Hadoop supports almost all well-known formats in the world, be it a text file, CSV, Excel. See, Excel and all, it will have to provide additional programs to deal with Excel sheet or Word document and all. But yes, we can say Hadoop provides it. End of the day, it's a program, it's set of programs. So as long as you have capability to write programs to deal with Excel sheets, you can do it in Hadoop also. Okay, Sandeep, one more question. Can you mix Windows and Linux mix type? No, I don't think there is such implementation anywhere available. But Hadoop is a system which is primarily designed to work with Linux-based operating system. But nowadays, Microsoft is offering a Windows-based Hadoop also. So if you want to run Hadoop programs, earlier was the case where we have to go and have a Hadoop based cluster, which will be based on Linux operating system only. But now Microsoft had partnered with a company called Hortonworks, which is one of the very big Hadoop player. And they have rewritten the entire Hadoop in .NET actually, because Microsoft is a company which hates Java. You know, Microsoft doesn't deal with any product which is uh, written in Java. Hadoop is actually written in Java. So Microsoft stayed away itself from the Java-based Hadoop. But because Hadoop is so successful in market, and Microsoft also want to get into the race, and they are sitting on a huge amount of money, of course. So what they did, they simply partnered with Hortonworks company, and they have rewritten the entire Hadoop in .NET. Now they are offering Hadoop on Azure, and I'm sure you would have heard about the node Azure. It's a Windows cloud platform, and now on the Windows cloud platform, they are offering this Hadoop also. So Hadoop on Azure is something that's hot in market nowadays. Okay, good. So continuing my discussion. So this is about HDFS, right? I hope you got a fair overview of what HDFS is about, and then the other one, MapReduce, it's a processing layer. So here HDFS deals with storage aspects of big data, right? And this MapReduce deals with the processing aspects of that big data. So we'll go and write a program, and again the program can be written in any language of your choice. It could be C, C++, Java, Python, Perl, or any other language of your choice. Go and execute the program, and of course, as you can guess, we will go and submit the program again to master, and we need not to bother about how many slaves are there, how many workers are actually working on it. So all your that is all transparent to us. We need not to look into what's happening behind the screens, and master in turn will go and assign the task of executing the program on different computers. So we can say on this data a task is working, on this data another task is working, and of course all of them will work in parallel. And if any sharing is required, intermediate data produced by this and this, if any sharing is required, there is another phase where those intermediate data collected from different computers will be mixed together, and then we'll have something called reduce phase, where data will be processed further. So with the concept of map reduce, we can go and solve wide variety of business problems, and we can go and write programs in any language of our choice. And of course, for a map reduce program to work, the underlying storage, whatever that I'm talking about here, the split 0, split 1, the underlying storage is assumed to be HDFS. Of course, for testing purpose, if you want, we can even go and run MapReduce program on local Unix file system. That is definitely possible. But in a typical productionized Hadoop environment, MapReduce reads the data from HDFS, runs some programs against that, and go and stores the results back onto HDFS. This is how it works, right? Uh, Is MapReduce can run on all the clusters? Yes. Srinivas Naidu, yes, definitely. MapReduce is a program that run on uh, a set of computers. Again, is it going to run on all the computers? Yes, it's going to run on all the computers if you give a huge amount of data as input to it. So it all depends upon how much input you are providing. If you provide a huge amount of input, definitely all the computers will be involved in running the program on that data. But if you provide only small amount of data as input, maybe not all computers will be used, only few computers will be used. Can we establish relation between Hadoop and cloud network? Yeah, Rajiv, I need to know more, little more about the question, but let me answer what I understood. We can actually make Hadoop cluster in the cloud. What I mean by that statement is, say you are a Amazon customer and you are using something on Amazon's EC2, Amazon's Elastic Computing 2. And if you want to make a Hadoop cluster on demand, which means I want to build a Hadoop cluster quickly, and my cluster size should be 20 computers. uh, if this is what is your requirement, two ways are there. You can go and purchase hardware of 20 computers. You can go and purchase the network cables, whatever. You can go and hire a Hadoop consultant like me. I can go to the office and I will install Hadoop cluster on your premises, and I will go and write a program, and then you are going to pay money to me. So here, you're paying to multiple things, like you have to go and purchase the hardware, you have to go and set your network environment and Hadoop software, right? You have to go and buy the Hadoop software. So when I say buy Hadoop software, there's a catch, of course. Hadoop is an open source software. Still, to provide to get the support, we might have to buy license, and then you have to go and hire people like me to provide a implementation, and then you will actually get your Hadoop cluster up and running, and you will be able to solve your problem. However, instead of going through this route, if you decided to go with a cloud-based setup, you can go to Amazon and say, Amazon, I'm looking for a Hadoop cluster made out of 20 computers. Please provide me. So what Amazon will do, they will simply go and run a program just at a button click. A 20 computers will be spawned. That is what is cloud is, of course. And then a cluster can be made out of those computers, those 20 computers quickly. And then Amazon will send you an automated email saying that, hey, your Hadoop cluster is ready and we have installed so and so software and you can go and use it. Now, your company will still go and hire me, who I will actually go and run those programs to do the overall processing. So in that way, what we are essentially talking about is, nowadays many companies are leveraging the cloud-based setups to quickly build the Hadoop cluster. And one more advantage of the cloud-based setup is you can go and dismantle the Hadoop cluster whenever you don't want. Whenever you are done with your work and you don't want to pay hardware costs anymore, you can simply say, I am done with my work. I am ready to return these computers, and I will not pay any money more to you. So cloud is about that, and then Hadoop on cloud is something that is very hot in the market nowadays. Rajiv, I hope that answered your question. If not, please put your question again. All right. So moving on. Good. So as I said, this uh, as you can see here, HDFS is a component, right? And then this is a MapReduce. So we have two different versions of MapReduce right now available in the market: Hadoop 1.x and Hadoop 2.x. And if you see that data storage, even though I'm talking about HDFS, but now Rajiv just raised a point that the cloud-based storage, that is Amazon S3 simple storage system, right? Then we have another system called MapRs, MapRF. We have HBase, we have cloud storage. This is the area where we can talk about multiple storage types, and then we have a basic processing layer, that is your MapReduce in HDFS, And then on top of this MapReduce and HDFS, we have an abstraction layer like Hive, which is a complete SQL environment. So those of you who know SQL, you already know Hive. No, if that is the case, Anil, why would I ever need to learn Hive? The differentiator it is big data. In case of Oracle or DB2 or MySQL, uh, if the database size goes beyond certain limits, the database will start hanging. The database will, keep creeping. So that's where Hive will come into, and we can go and store hundreds of billions of records of data into Hive, and we can go and run SQL queries on the data. That's the power of Hive. Now we can go and run high query, regular SQL queries on any amount of data. There is no limit as such. So if at all you are experiencing latency, if at all you are facing issues, you can go and add more computers to your network, as simple as such. And similarly, we have something called PIG. It's a another another Hadoop ecosystem component using which we can go and process that big data, but this time processing will be much easier and efficient. Maybe I can show you an example, but how are we doing with respect to time? I think I have consumed an hour already. Did I? Approximately an hour. But let me show you something interesting. If you look at a pig example, I hope uh, I hope everybody is doing good. Uh, yeah, Rajiv and Srinivas, if you have a question, please go ahead, sir. Rajiv and Srinivas, if you have any question, please go ahead. It looks like you have raised your hand, so if you have a question, please go ahead. Okay, good. So here is my pig PPT. Just look at this and just read this problem. So if I have to solve this problem involving two different data sets, I'll simply go and load one file. I'll go and load another file, and I'll go and filter it by age because I'm interested in only between 25 and 30. Sorry, 18 and 25. Right? Join by name, group by URL. Go and count your clicks, order the clicks, and take top five. This is how we'll go and solve the problem algorithmically. Right now, if I have to write a Java program, or if I have to write a map reduce program to solve this problem, this much is the code that I have to write. It's a map reduce code and it's a plain Java code. And this is actually some 160, 170 lines of Java code, right? Now the same problem, if I'm allowed to use pig to solve, this is the code that I need to write. And look at the statement, load users, filter it, load pages, join them together, group by, for each, order by, limit, store. So for most of you, for all of you, of course, this is the first time you are looking at a pig script, but you can easily take a guess on what is that each and every statement is doing. It is loading, it is filtering, it is again loading, it is joining, it is performing a group by, it is performing a for each, it's a loop, it's ordering, it's limiting, and it is storing. So without knowing much about pig, you know what's happening in this script. So in that way, I can say, hey, learning pig is very easy. Whereas for those who don't know Java, understanding this code is simply a big task. But understanding this or learning this is definitely an easier task. So pig is about an abstraction, and we need not to write the programs on our own. But end of the day, what will happen is when you go and try to execute this program, pig Latin script, a pig in turn will generate this program on its own. So in a way, it is providing us an abstraction. Those of us who don't want to write Java programs, we can leverage this Pix expertise. We'll simply go and write this Pix script, and the Pix script in turn gets converted into this code, and this code is what is actually going to run. And of course, this code will anyway run in distributed parallel manner, using which we'll actually get the advantage of parallelization. That's about Pig component, right? Good. Any questions? Any questions on this? Or how do you feel about the components like Hive, Pig, HDFS, MapReduce? Any uh, feedback you want to share? Rajiv, nowadays most of the manufacturing companies want to implement Internet of Things for predictive. Yeah, using Hadoop, we can decide. Yes, Rajiv. Yeah, that's point is a very nice point. So, I mean, those of you who haven't heard about Internet of Things, what it means is connecting devices to internet. The device can be your washing machine at your home. Device could be my mobile. Device could be a manufacturing equipment sitting in a manufacturing plant. Device could be a handheld watch that I have on my wrist. No, and go and collect the data continuously from your device through sensors or whatever. And because it's connected to internet, if at all any abnormality is detected, go and take a corrective action then and there. So Internet of Things is something that's very hot in the market, and interestingly, this Internet of Things is something. Uh, the enabler is actually Hadoop behind the screens. The enabler for Internet of Things is Hadoop, of course. Right? Good. So continuing my discussion. So Pig is the one that we just talked about. Similarly, we have something called Avro, we have Mahout, we have Scoop. So Scoop is another interesting component. It's a data collection component. Somebody had asked this question: hey, does Hadoop deals with collecting the data? So Scoop and Flume Chukwa, these three components, if you see, these three components are collection components. Of course, there are few more, but I have given only three. So what they will do, Scoop, for example, it will help you to collect the data or load the data from Oracle into Hadoop, or from DB2 into Hadoop, or from MySQL into Hadoop, or export also. Like if you have some data in Hadoop, you can go and upload it into Oracle, or into DB2, or into SQL Server, or any other database for that matter. So Scoop is a component using which we can import or export from R to normal RDBMSs. And similarly, using Flume and Chukwa, you can collect the data from wide variety of sources. So the Internet of Things that Raju brought up the point. Right? So the Internet of Things is through this Flume or through Spark streaming, or some other collection components. So after looking at this many components, of course, the list whatever there in my slide, they are actually only subset. There are many more components which are not listed in this slide, but they are there right now running in production. So if you see, there are 30 plus components are available in Hadoop family right now, right? And Hadoop, by looking at this many components, can somebody say what Hadoop is all about? Is it a framework? Is it a language? Is it a database? What it is? Okay, nice, Neeraj. Yeah, using Hive or using Pig or using MapReduce, we can perform ETL. Our company is a classic example there. Uh, we have good number of Informatica jobs which are currently running in production, and because of the throughput requirement that we started rewriting those jobs using this Spark and Hadoop based jobs, and we are finding ways to parallelize that. Informatica, as you know, there's a age-old traditional technology. I think nowadays they also started providing parallelization advantages, but we at our company had already converted some of the Informatica-based ETL jobs into Hadoop-based ETL processing. And we in one project we have used a PIG, the one that we have just seen. In another project we have used something called Spark, which is not there in the slide, but that is another component that we are using in our company. All right, so I think that's all I have from my side, and I don't know whether Skillbooth has shared you the content or not, but the content I can say is a truly world-class content, um, and the delivery is going to be equally world-class. And if you see the coverage that I'm providing, right? HDFS, MapReduce, Hive, Scoop, Spark and Kafka, which is some very recent component, HBase or Mongo, Woozy. So these are the topics that I'll be covering, and I hope you have this document, or we have this already on Skillwood's website also. The same data we have it on Skillwood's website also. So whatever we have it on our content, we are going to deliver that. Yeah, Sandeep, just to answer your question, look at this. I have a G drive, and you can see it's having shared folder, which is containing this many folders, and we have PPTs also. These PPTs all will be shared with my participants. It's not just PPT. I have so much to share with you, right? Your sample resumes, books, setup videos, sample resumes of development, and then distribution documents. Like, you know, Cloudera is a trainer, a Hadoop trainer, right? World's number one Hadoop trainer, we can say. And Cloudera Hadoop training material, I have it with me, like this one. It's a 644 pages video, I mean, material, so you can use this. So this is all the stuff that I will be sharing with my all my participants, right? And we have good number of exercises to do. We have good number of interview questions as well. As I said, I have 800 plus previous students, so they'll keep collecting. They will keep giving interviews and will keep collecting questions. So I have very good material to share with you, of course. And I have sample projects as well, right? So these are all some of the, I can say I have 8 to 10 projects are there, and I will explain at least four projects in my class. And those of you who are interested to do some projects, you can actually participate in such projects as well. Yeah, more we get, it will be helpful. Yeah, definitely, Sandeep. I'll provide all that I can. So, what roles a person can look for a senior level like me in 26 years? So, yeah, you can actually look for business development manager position where interacting the clients and providing solutions by staying at an on-site customer place, or you can even look for data scientist related career. You know, data scientist is something which is useful for people with good domain expertise. So depending upon your own domain expertise, you can choose the areas. And Hadoop with the data science related skill set is something that will be very suitable to your profile, Sandeep. Okay, good. So I think I have taken more than what I initially committed. We started at 8:45, so I took 1 hour 15 minutes of time, but I think that's well spent. Can you share your contact details if you want to get back? Yeah, Sandeep, I can share, but yeah, best way to contact me is through Skillbooth, and I can provide my email ID. Here is my email ID, les.kumar16 @gmail.
Hi, Anil. I just have one last question from my side.
Yeah, sure.
In typical telecom or networking environment in which I am part of, what we see so far traditionally is a development team. Basically, we call them as software teams who write code and does unit testing kind of thing. and then it moves on to the test team.
Right.
Could be feature test, integration testing, or system testing. So that's a so we broadly have two different teams within the development environment. One is focused exclusively on the writing code, and other team is testing the piece of code on the entire router or switch in which I'm being part of. Do we have similar kind of roles in the Hadoop environment as well, or it is going to be a DevOps kind of stuff where everybody looks at the scripting and everybody looks at testing the piece as well?
We will have similar roles in Hadoop environment as well, sir. You know, um, in broadly, if you go and classify broadly, Hadoop roles will be divided into four different roles. One is Hadoop developer. Second one is Hadoop administrator. Third one is Hadoop database HBase developer or HBase administrator. So Hadoop database developer, and the fourth one is a data scientist. Though we can divide them, but if you look at my own position, I do all four jobs together. You know, at least initially I have done all these four, but now once this team is stabilized, once the project is moved to production, we'll have dedicated Hadoop administrators, we'll have dedicated data scientists, we'll have dedicated team members to do their specific job. It really depends upon which stage the company is in, and there will be definitely different roles, and we will have Hadoop testers also, big data testers also, though it is very new, but we have some positions on big data testing also nowadays.
Okay, thank you.
Okay, sure. We have a question from Neeraj. He's asking, do we really need to know Java to make a shift into Hadoop? Yeah, that's a good question, Neeraj. I will say yes, and I will also say no. As you can see here, uh, if you look at the pig or hive or data scientist related work, Java knowledge is not mandatory, but it's always good to have. So I can say it's good to have, but not mandatory to have Java knowledge. And even if you want to have it, we need only basic core Java concepts like struts, springs, advanced concepts are not required. So basic core Java is actually required. I mean, I'll say basic core Java is required. So, I mean, those of you who are coming from non-Java background, to help you learn core Java quickly, I have few Java recorded sessions available here. So that could be helpful to those who want to learn core Java quickly. All right. So I think we are done with the session. Any other questions before we wind up?
Hey, thanks, and this was quite useful. Last 1 hour that we had spent on the intro part of it. Thank you very much for
Yeah.
your time.
Thank you all for joining. Uh, those of you who are interested to attend a class, uh, class is going to be at 9 p.m. today, but from tomorrow onwards, it's going to be 6 p.m. So those of you who are interested, if you want, you can attend today's class without paying any money, and then you can decide also. No, we are not in a hurry to collect money from anyone. So you can listen to today's class, and if you like, then only you can make a payment. And timings are something that Mr. Krishna Reddy is going to communicate with you all, and you can take information on that. Today it's going to start at 9 p.m. Rajiv, and from next class onwards it's going to be at 6 p.m. Only for today it's going to start at 9 p.m. up to 11 p.m. Yeah, Sandeep, it's going to be webinar only, and we will be sending you a separate invitation. Everybody will get a separate invitation. It's going to be webinar only, and Mr. Krishna or someone from Skill Booth are going to contact you, and they will share the webinar link with you all. Okay, thank you all for attending. Have a good day.